The very last part of step 11 is all about solving a right triangle. Now, the nice thing is you know how to solve a right triangle already. That just means find the side lengths and find the missing angles. And we've already done that in video B. So let's just go over a few little details here. One thing to note that capital letters used are for the angles. Lowercase letters are for the side lengths. And you'll notice that the side opposite angle Z is little z. The side opposite angle X is little x. Therefore, the side opposite angle Y is going to be little y. So we need to find all three of these, X, Y, Z, for the angles. And to the nearest degree, that's what it says. And then we need little x, little y, little z for the side lengths. So first off, we should really start by labeling everything that we know. We know that angle X is 35 degrees. We know that angle Z is 90 degrees. We know that three angles of a triangle are 180. So if I take away 90, I'm left with 90. If I take away 35, I'm left with 55. So we're halfway there. We also know that little y is 10. So all that's left is to find little x and little z. So we go back to labeling things H, O, and A. Side Z in this problem will always be the hypotenuse. With respect to this angle, you should always try to use the angle that's provided to you in case you made a mistake finding your other angle. This is my opposite side, and this is my adjacent side. So to find x, I don't know the hypotenuse, so I'm not going to use that. I do know that I'm trying to find x, and I know the adjacent. So to find x, we're going to say that the tangent of 35 degrees is the opposite over the adjacent. Punching this on the calculator, we can easily figure out what x equals. Seven is our answer. And I believe side lengths are to the nearest tenth, so we should probably call that 7.0. Right, now we can find our hypotenuse. Now we do want to know about this. We know about the adjacent. Again, we now know that x right here is 7. We could use that, but if we made a mistake, the mistake will carry through. So we always want to try to focus on what we're given and what we want to find. So I'm going to use cosine of 35 degrees is the adjacent over the hypotenuse. Multiplying both sides by z, we have z cosine 35 equals 10. Then we divide both sides by the cosine of 35. And we get our answer for z, 10 divided by cosine of 35. 12.2. All right, let's take a look at B. It's a little bit different. We know that we need angle J, K, and L. We need little j, little k, and little l. We know that angle K is 90. It's marked. We don't know little k. We know that the side opposite angle L, this is little l, it's 8. We know little j is 11, side j. So unlike the last time where we could just subtract and figure out these missing angles, we're going to have to do a little bit more work for this one. All right, so it doesn't matter which angle we want to start with. If we want to find j because it comes first, j becomes our theta. That is our angle. Everything that we're going to mark is with respect to angle J. So K is going to be the hypotenuse no matter what. 11 is going to be the opposite. And L is going to be the adjacent. So now we could find angle J because we know what the opposite is and we know what the adjacent is. So I could just use tangent, the tangent of angle J, or again, you could put theta if you want, but just to keep track of which angle we're on, I'm going to say angle J, which is theta, is the opposite over the adjacent. And again, to find that angle measure, just like video B started with today, tangent inverse of tangent J, tangent inverse of 11 over 8. That's going to give us our angle measure. Tangent inverse of 11 over 8. 53.97 to the nearest degree. So we call that 54 degrees. Now again, you could restructure your triangle and rename your sides so that you don't have to use this 54 to find the other angle measure, but it is a time saver. If you feel confident that you did the work right, you could just subtract the 54 from 90 and get 36. Now all that's left is K. So pick one of these angles. This one's 54. This one's 36. We know that if I'm using angle 54, angle J, and I want to find the hypotenuse, I can either use the cosine or the sine. It really doesn't make a difference because they're both provided. I'm just going to say that the sine of 54 degrees is the opposite over the hypotenuse. So again, solving 11 divided by the sine of 54, I know that that side is 13.6. Go ahead and pause the video and try 8A and 8B. Here are the answers for 8A and 8B. That concludes all of our notes for step 11.